Welcome back, everybody, to another deep dive. We are going way out there this time to the edge of the solar system to talk about Planet 9. You sent some articles over, and just from skimming them, I could tell this is going to be really interesting.
Yeah, Planet 9 has been quite the topic in astronomy the last few years.
And for good reason.
Yeah. It's such a cool story of detective work by scientists that are using these subtle gravitational clues to find a hidden world.
A huge world from what I saw. It could be like 5 to 10 times the mass of Earth. I mean, that's way bigger than anything else we know of out past Neptune.
Right. And what's so cool is how this whole idea even came about. It's not like someone just pointed a telescope randomly and found a new planet.
Right.
It all started with these weird orbits of objects way out there in the Kuiper Belt.
Okay, so astronomers noticed that these objects weren't moving how they expected, based on what we know about gravity in the solar system.
Yeah. They found that these objects, their orbits were all clustered together in a way that just couldn't be random. It's like something massive is out there sort of shepherding them around.
That's so cool. It reminds me of how Neptune was discovered. Astronomers noticed that Uranus wasn't moving on its predicted path, and they realized there must be another planet out there. Pulling on it, and boom, Neptune.
Totally. Similar thinking here. With these Kuiper Belt objects, based on how weird their orbits are, scientists have run all these simulations and models trying to figure out where Planet 9 might be and how big it is.
And what have those models shown? I mean, besides it being huge.
Well, they think Planet 9 could be orbiting 20 times farther out than Neptune.
Wow.
That's so far, which kind of explains why we haven't actually seen it yet.
Yeah, trying to spot something that far away must be, I don't know, like spotting a firefly in a football stadium or something. But if we haven't seen it directly, how do scientists know it's really there?
Yeah, well, good point. Planet 9 is still just a hypothesis right now. The clustered orbits are pretty good evidence, but there could be some other explanation we haven't thought of yet.
Okay, so what are some alternative explanations?
Well, some people think that instead of one big planet, maybe there are tons of smaller objects out there whose gravity combines to make this effect.
Oh, interesting. Like instead of one shepherd, it's a whole flock.
Yeah, exactly. But the single planet idea still seems to be the most popular one. And that leads us to an even more interesting twist.
Okay, I think I know where you're going with this.
Yeah.
In the articles you sent, there was this totally wild idea. Maybe Planet 9 isn't a planet at all.
Right. It could be something way more exotic.
Yeah, a few years ago, some physicists proposed that.
Yeah.
What if what we're looking for is actually a primordial black hole?
Yeah.
Okay, so for those of us who haven't thought about black holes in a while, can we get a quick recap?
Sure. So basically, a black hole, it's this super dense area where gravity is so strong nothing can escape, not even light.
Right.
Most black holes form when huge stars die and collapse. But these primordial ones are different.
Okay, how are they different?
The idea is that they formed right after the Big Bang.
Oh, wow.
When the universe was super dense and hot. And some of that matter could have collapsed into these tiny black holes.
Tiny. How tiny are we talking?
I mean, estimates vary, but some think they could be as small as a bowling ball.
Wait, a bowling ball with the gravity of a planet.
Yeah, even though they're so small, they're so dense that their gravity would be super strong.
Wow, so it's like this cosmic David and Goliath situation, this little black hole thrown around these huge icy objects.
Yeah, exactly. And that just raises even more questions and possibilities.
Totally. But one thing I got to ask, if this thing is so small and far away, how do we even start looking for it?
Wow. That's where things get really tough. Directly observing a primordial black hole that far away would be almost impossible with what we have now.
Yeah, I can imagine. It's not going to be shining like a star, right?
No, but there are some really clever ways that astronomers are trying to find it indirectly. One way is to look for this thing called gravitational lensing.
Oh, yeah, I remember reading about that.
Yeah.
That's where gravity from something massive bends the light coming from behind it, like a cosmic magnifying glass.
Right. So if there's a black hole out there, it would distort the light from stars or galaxies behind it, making things look kind of warped.
So astronomers are basically looking for these tiny distortions in the fabric of space.
That's one way, yeah. And there are other ways too, like looking for bursts of radiation that happen when black holes interact with stuff around them.
So even though we can't see it directly, there are ways to track down this cosmic phantom.
Yep. The hunt is on. And scientists are super excited because finding a primordial black hole in our solar system would be huge.
Okay, now I am really curious. Let's get into why this would be such a big deal.
Okay.
Like, what would this mean for our understanding of everything?
First of all, it would totally change how we think about the solar system.
Right.
It means that our neighborhood is even stranger and more diverse than we thought.
Like finding out your quiet street has a secret portal to another dimension in the backyard.
Haha, exactly. But besides just being super cool, this would have massive implications for astrophysics and cosmology, like huge.
Okay, well, I'm all ears. What kind of implications?
Okay, so remember those primordial black holes are thought to have formed right after the Big Bang.
Yeah, like cosmic time capsules.
Right. So studying one up close would be like looking back at the early universe.
Wow.
And that would give us so much information about how the cosmos became what it is today.
It'd be like having a piece of the Big Bang right here in our solar system.
Yeah, it doesn't stop there. Primordial black holes could also be a big deal for understanding dark matter.
Ah, yes. Dark matter, the mysterious stuff, that makes up most of the universe. But we can't even see it.
Right. We know it's out there because of its gravity. It affects galaxies and stuff.
Oh.
But we still have no idea what it's made of.
Primordial black holes are one of the top candidates.
Yeah. The idea is if enough of these black holes formed in the early universe, they could be that missing mass that we call dark matter.
So finding one would be huge for that theory.
It would be a big piece of the puzzle for sure.
Okay, so we've got this connection to the early universe, possible clues about dark matter. What else? Are there any other big implications?
Well, there's also the question of how a primordial black hole even got here to the solar system.
That's a good point. I mean,
Ew.
if they formed way back then, wouldn't they be spread out all over the planet?
Yeah, that's what we think. But
Yeah.
as the universe changed and galaxies formed, these black holes could have been captured by the gravity of stars and planets.
Well, so like one of these ancient black holes
You're just saying-
wandered too close to us
Yeah.
and got stuck.
Yeah, it's all about cosmic chance. But over billions of years, even really unlikely things can happen.
Makes you wonder what else is out there
Right.
and all that vastness.
It does. Every new thing we find just seems to open up more mysteries.
Okay, so back to the search itself. For this mysterious object, whether it's Planet 9 or a black hole, what are the biggest challenges? I'm trying to find something so small and far away.
Wow. Like we said, directly seeing it is super hard. These things would be really faint, not giving off much light, and the distances are just mind-boggling. It's a needle in a cosmic haystack.
So what are astronomers doing to try to overcome
A
that?
big hope is this new telescope called the Vera C. Rubin Observatory in Chile. It should be up and running pretty soon.
Yeah, I've heard about that. It's supposed to be a total game changer.
It is. It's designed to scan the whole southern sky every few nights, taking incredibly detailed pictures.
So it's like the superpowered time-lapse camera for space.
Yeah. And with all that data, astronomers hope to see tiny changes in the positions of stars over time. And those changes could point to the gravity of a hidden planet or a black hole.
But even if we can't see the object itself, we can see how it affects the things around it.
Exactly. It's like
Yeah.
watching a puppet show. You can't see the puppeteer, but you see the puppets moving, so you know someone's there.
I love that analogy.
And another thing we can look for is bursts of radiation that happen when a black hole interacts with stuff nearby.
Oh, yeah, I read about that. Something about black holes eating comets.
Right. As stuff falls into a black hole, it gets superheated and blasts out radiation.
So it's like a cosmic feeding frenzy. And the black hole flashes as it gobbles things up.
Yeah, something like that. And those flashes would be really faint, hard to see. But we're developing new instruments that might be able to catch them.
Sounds like astronomers are trying everything. But let's say they do find it. What then? How do we know for sure if it's a planet or a black hole?
That's when it gets really exciting. We'd need a whole bunch of observations and some serious analysis to figure out what we're dealing
What
with.
kind of observations?
Well, a big difference between a planet and a black hole is how they interact with light. A planet would reflect sunlight, even if it's just a tiny bit. A black hole would just swallow all the light.
So it's about looking for reflected light.
Yeah,
Like,
basically. But it's not that simple. Even if we saw a little glimmer, it might not rule out a black hole. Because there's this thing called Hawking radiation, where black holes actually can give off a little bit of light because of quantum stuff.
Oh, wow. Okay, so it's
Yeah.
not a clear-cut difference then. Are there other ways to tell them apart?
Yeah. Another big difference is their gravity. A black hole would warp space-time way more than a planet with the same mass.
Yeah. Back to that gravitational lensing thing.
Yep, by looking closely at how light bends around the object, we could figure out how massive it is and how dense.
And I'm guessing a black hole would be much denser than even a super Earth.
Oh yeah, way denser. Black holes cram a crazy amount of mass into a tiny space.
So by looking at the light and the gravity, astronomers could put together a pretty strong case for whether it's a planet or a black hole.
Exactly. It would be a long process. Lots of scientists working together, astronomers, physicists, computer people,
Yeah.
to study all the data and reach a conclusion.
Like a real-life scientific detective story. Each clue getting us closer to solving this mystery.
It is. And a big one. Finding a new planet would be cool, of course, but a primordial black hole would be revolutionary. It would change so much about how we understand the universe.
Okay, speaking of those implications,
Mhm.
I think it's time to really dig into those. We've talked about how finding a primordial black hole would be like a window to the early universe and how it could maybe even solve the mystery of dark matter. But what else makes this so
Look,
groundbreaking?
they could change how we think about black holes themselves. Remember how I said that the ones we usually see come from dying stars?
Right.
Well, these primordial ones formed way differently, like right after the Big Bang.
So it's like two separate recipes for making black holes.
Why?
One with dead stars
Yeah.
and one from the Big Bang itself.
Exactly. And if this thing out there really is primordial, it would let us study this other kind of black hole up close. It'd be like a lab for understanding the crazy conditions of the early universe.
That's awesome. And this would probably also have implications for how we think about gravity itself, wouldn't it? I mean, black holes are where Einstein's theories really get put to the test.
Totally. By watching how a primordial black hole acts, we could see if general relativity holds up, or maybe even find some new stuff about gravity that we didn't know before.
So it's not just about finding a new thing in space. It's about like pushing the boundaries of what we know about the universe and how it works.
Exactly. It's about those deep mysteries and trying to figure out our place in all of it.
Okay. I'm curious from your perspective, what are some of the biggest unanswered questions about Planet 9 or this black hole? Whichever it is.
Well, the biggest one is, of course, what is it? Is it a planet? A black hole? Or something else entirely? Once we know that, a whole bunch of new questions pop up.
Like,
Well, if it's a planet, how did it form out there? What's it made of? Does it have any moons? Could it have life? And if it's a black hole, how did it end up in our solar system in the first place? What does that mean for us having it as a neighbor?
so many questions. It's like you open one chapter in this cosmic mystery and find a whole new set of puzzles.
Exactly. That's what's so cool about science, though. Every discovery just leads to more questions, which pushes us to keep exploring.
Okay, before we finish up, here's a thought. Let's imagine it is a black hole, a primordial one. What would that tell us about other primordial black holes? Could there be others out there? Maybe even closer than this one?
That's a great question. If we found one here, it would mean they might not be so rare after all. The early universe could have been full of them, scattered all over the galaxy, maybe even in our own solar system somewhere else.
So there could be more than one, hanging out with us cosmically.
Possibly. And that just opens up even more to explore. Imagine if we could find them, study these. Ancient leftovers from the Big Bang.
Wow, that's just mind-blowing. It'd be like a treasure hunt across the universe.
Yeah. And who knows? What else might be out there, waiting to be found?
Well, on that note, I think it's time to wrap up our deep dive into the mysteries of Planet 9.
Planet 9/primordial black hole. I guess we need a better name once we figure out what it is.
Yeah, for sure.
But no matter what it turns out to be, this has been an incredible journey, looking at the evidence, the theories, and just the sheer awe-inspiring nature of it all.
And it's not over yet. The search goes on. And with all the amazing new telescopes and tools we're building, we might be on the verge of finally cracking this case.
And who knows what other incredible things we'll discover along the way. So everyone listening, thanks for joining us on this deep dive. Keep exploring, keep asking those questions, and keep looking up at the stars. The universe is full of mysteries, and the thrill of discovery is out there for anyone who wants to find it.